on to the equation part of the retest. There are 4 questions on the review, all making sure that you know how to solve the equation. So, a couple things. First of all, when you see something raised to a power, as long as the base is by itself, you'll undo that by taking the root. When you have a root, like a square root, fifth root, you're going to undo that by raising it to a power. So there's really 2 kind of questions. One, where you have the root and you have to raise it to a power, like these 2, and one where you have it raised to a power and then you have to take the root of that. All right, so number 9. If you look at number 9, it's x minus 3 to the 5th equals 64. So to undo something raised to the 5th power, we're going to take the 5th root. So we have to do that to both sides. And again, taking the 5th root just undoes raising to the 5th power. So over on the left side, I'm left with x minus 3. On the right side, we have to be able to take the 5th root of 64. So again, to do that, remember, you go to the math button. Okay? So you have to type in 5, tell it what roots you want to take, then you hit that math button. And when you hit the math button, you'll see this one that says the xth root. So you're going to hit that, go down to number 5. So this says I'm going to take the 5th root of, and I want to take the 5th root of 64. So I get, and it says to round the nearest hundredth, 2.29. There's a 7 here, so that means I have to round that 9 up to a 0. So it's 2.30 rounded to the nearest hundredth. So 2.30. And then to solve that equation, we add 3, so I get 5.30. So all we have to do is take the 5th root and then add 3. All right? Now, if the exponent or root is not by itself, so look at this. This is x to the 3/2. I have to get that base raised to the 3/2 by itself. So I first have to subtract 17. So I get 2x to the 3/2 equals 12. I need to divide by 2. You have to get the base by itself. And I get 6. Now, with this one, a couple ways you could do it. You could think of this as the square root, because really this means the square root of x to the 3rd, and undo it in 2 steps. You could square both sides to undo the square root, and then you could take the cubed root to get x by itself. So you technically could do it in 2 steps. Usually what we look at is we say if something's raised to a power, to get it to be x to the 1st, we're going to raise it to the reciprocal power. So I'm going to raise it to the 2/3 power. Because then when I take 3/2 and multiply it by 2/3, I'm going to get x to the 1st. So if it's raised to a fractional power like that, easiest way to solve this is just raise it to the reciprocal power, which means over here I have to raise it to the reciprocal power. So I'm going to be left with x, because again, a power to a power, if I multiply those 2 numbers, I get 1. And then I have to figure out what 6 to the 2/3 is. A couple ways you could do it. Again, in radical form, that would be taking the cubed root of 6 and squaring it. Or taking the cubed root of 36. You could square the 6 first and just take the cubed root of 36. Or, you can use your calculator. You can say you want to take 6, raised to the, now my calculator goes up like this. If yours doesn't, put it in parentheses. Raised to the 2/3 power. So 2 divided by 3 power. Hit enter, and I get 3.30, because again, that 3rd digit is 1, so it's just 3.30. So all you did is you first get the base by itself. That's the key thing a lot of you are forgetting to do. And then you're going to raise it to the reciprocal power. And then just put that on your calculator, 6 raised to the 2/3, you should get 3.30. All right. Number 11 is similar to that, except for here is my base. It's that root that I have to get by itself. So I first have to subtract 6, and then I have to divide by 2. So I get the 5th root of 4x has to equal 3. So again, you have to get whatever that base is, so in this case it's the root, you have to get that by itself. Now to undo a 5th root, I'm going to raise it to the 5th power. So I'm going to get over here, because I'm just raising all of that to the 5th, I'm just left with 4x. Here I have to take 3 to the 5th power, so I use my calculator, I take 3 raised to the 5th, and I get an answer of 243. So that equals 243, and now all I need to do is divide by 4. So if you take 243 and divide it by 4, you should get 60.75. And all of these you should be able to check by taking that number, plugging it back into this original equation. Now because you've rounded sometimes, I guess this one we didn't really round, but in some of these other ones up here you rounded, so you wouldn't get the exact answer, but you get something pretty close. If I took 5.3 minus 3, raised it to the 5th power, I'd get something very close to 64. It would be off a little bit because we did round that number. All right, and then the last one, this is that one that you have to be careful of because you're going to undo the square root. Again, the square root is by itself, so I'm going to square it, but over here, because there's two terms, I have to square that entire side. So on this side, I'm undoing the square root. I'm just left with x plus 22. On this side, I have to take x plus 2 times x plus 2. So if you need to write it out, do that over on the side. You're going to distribute the x, you get x squared plus 2x. Distribute the 2, 2x plus 4. So when I multiply x plus 2 by itself, is what this is telling me to do, I get x squared plus 4x plus 4. So now I have a quadratic, and we have to solve that. So we have to subtract x and subtract 22. So if I subtract an x on each side, I'll be left with 3x on the right side. If I subtract 22, I'll be left with a negative 18. So then I want to try to factor this if I can. If I can't, we have to use quadratic formula. We need a pair of factors of negative 18 that adds up to 3. So that would be a plus 6 and a minus 3. Adds up to 3, multiplies to give me negative 18. And so if x plus 6 equals 0, one of my solutions possibly is x equals negative 6. If x minus 3 equals 0, I get x equals 3. Now why did I say possibly? Because you do have to make sure you plug this back in. If I put in negative 6, negative 6 plus 12 is 16. Square root of 16, does that equal negative 6 plus 2? It does not equal, 16 does not equal negative 4. So I have to cross that one off. If I put in a 3, I get the square root of 25. Does that equal 3 plus 2, which is 5? Yes, it does. So that answer is correct. Sometimes they both will work. Possibly they neither of them could work, or one of the two could work. So you do have to plug them back into the original problem to see if they work. Okay? So again, with all of these, you're always making sure you get the base by itself. No matter what it looks like, you always want to get the base or the root by itself. Then you undo it. If it's a square root, you square both sides. Now, if you have a binomial, you have to square that whole side. To get rid of a 5th root, once we got it by itself, we raise to the 5th power. If you have a root, or if you have a power, then you have to take the root to solve it. So with this one, to undo something raised to the 5th, we had to take the 5th root of that. And again, if it comes out to something where you have something like x to the 3/2, the easiest way to solve that one is raise it to the reciprocal power. So really, those are the only things you have to worry about when you're solving, and you need to make sure you round to the nearest hundredth.